to go back to the basics a little bit with you guys. So forget about constructions, forget about your compass for a minute. Think back to like way back at the beginning of geometry, some of the very first stuff we knew. We actually did this in our little geometry unit in 4th grade. There was some 4th grade geometry. This was part of that. So I'm pretty sure you guys remember. If you have an isosceles triangle, you know that this side is equal to this side, right? And you know that this angle is equal to this angle. These are just properties of an isosceles triangle. And you know that if they had in your book, I'm not going to make this exact, but I'm just like, if this was a picture in your book, they would have put a little altitude going down the center. You know that if we saw that altitude cutting the isosceles down the center, that it actually cut this base exactly in half, right? And we also knew that it cut this angle exactly in half. These were all just properties of isosceles triangle we learned. Okay, if you have that in your head good, then you can do these constructions, because this is what all of these constructions are based off of. If I had this triangle and I had to cut the altitude myself, but I didn't know how, it wasn't drawn for me, it wasn't a picture in the book, I had to cut that altitude through there. I had to bisect that bottom base. I had to bisect those angles by creating this altitude myself. How would I do that if I don't have a ruler? Well, if I know that if I have an isosceles triangle and I drop an altitude, it's going to bisect that base. Think about what you could do. You could flip this around and have another isosceles triangle on the bottom. And that tip would line up so that it cut through exactly perpendicular across that base. So if I could come down here and draw these two legs, both exactly the same length. Then if I drop that altitude and it's cutting the base in half, I drop this altitude, it's cutting the base in half, that's the same base. So if I drew a line from one tip through to the other, I just made exactly perfect a perpendicular bisector. I cut that base in half. This is exactly perpendicular. I just made a perfect perpendicular bisector. That's what I need. I need to flip that triangle over so I have both tips to run through to create that perpendicular bisector. I think y'all understand that. So that is what I'm doing when I'm making a construction. If I'm given a base, think of that as the base of my triangle. Now, if I want to make two legs of the triangle that are both equal, I'm going to leave my compass the same. I'm going to go to one endpoint. I know it's going to meet up here in the middle somewhere, but I'm not sure exactly where. So I'm going to make myself a few points to go off of. I'm going to come to the other side. I'm making the leg for this side. Once I give myself a few points, I see where they cross. That's going to be the tip of my triangle. I'm going to do the same thing down below here because I want to make the bottom triangle too, because I just saw that I need both triangles to be able to draw the intersection through there to cut my line in half and to make sure it's perpendicular. So that's what I'm doing. I could, if you really wanted to, you could fill in these legs of this triangle same isosceles triangle stacked on top of itself. So when you drop an altitude, it's got to go through that vertex and through that vertex. So if it's running through both, then I know that it's my altitude, I know that it's perpendicular, I know that it bisected the base of that triangle in half. I just created a perpendicular bisector. So when I'm using my compass, all I'm doing is measuring the lengths of where do those sides of that triangle meet up there. That's why I'm making that arc. And where do they meet down here? That's why I'm making my arc. We save ourselves the trouble and don't draw the lines of the triangle, but that's how we are creating a perpendicular bisector. So, knowing this, I should be able to give you any random segment length. And you should be able to bisect it, because what you're doing, think about, is you're basically constructing an isosceles triangle on top of this thing, and you're constructing one down here as well. We're not going to draw the lines. We're using our imagination to save ourselves some steps. If I had the tip of an isosceles there and a tip of an isosceles there, and I drew a line from that vertex to that one, it would cut the base of my triangle in half, and it would do it at a perpendicular. That's how I'm creating that perpendicular bisector. That length is equal to that length, and that angle is perpendicular. I can do that whether it's a line segment by itself, whether it's the side of a triangle, wherever it is, you know how to make a perpendicular bisector now. What if I'm using this same perpendicular bisector method, or I think I am, and I come up on a problem where there's a line and I'm supposed to make a perpendicular, not that bisects this line, but that runs through this certain point T. Now what am I going to do? How is that going to change things? It's really not going to change things. Now T is the tip of my triangle. I'm going to kind of ignore all the rest of that line. I've still got triangle T here. So let me make triangle T. Alright, I just put my point of my compass on T, and I found two places for it to intersect my line that I was given, just so now this can be the base of my little triangle that I'm going to use to cut the perpendicular. So once I've got those 2 points, now I'm basically making those two isosceles triangles stacked on top of each other. I don't have to draw the lines, because I remember that when I measure these points out like this and find where they intersect, that's what I've done. I've created the tip of my triangle there. I've created the tip of my triangle there. So if I go through and connect through those two tips, I'm going to have a perpendicular, and it's going to be running through that point I was asked to put it through. What did I do? I basically created my two little triangles over here. And none of the rest of that line really even mattered. I just focused on my little triangles. Okay, let's look at an isosceles triangle again. So, again, same properties. If I have an isosceles triangle and I can manage to bisect this base into two equal segments, and I draw a line from the vertex down, that will be my altitude. Okay, remember? And the altitude, how am I going to find how to bisect this thing exactly? We just talked about if this length and that length are equal, okay, so it is an isosceles. I'm going to come down here and do the same thing. I'm going to form an isosceles triangle pointing down. And if I can go through the point of each of those vertex of the top isosceles triangle and the vertex of the one on the bottom. Remember, we can pretend this is actually a triangle down here, but I'm saving myself a step by not drawing this side. I don't need it. I just need to know where that point would end up in order to create that perpendicular. Okay, so what did I do when I did that? I made sure this side is equal to this side now. And when I did that, I made sure that was perpendicular also. And when I did that, what did it do to my angles? It cut that angle in half. Each of these angles is congruent as well. Now think about if we turned this thing sideways and you looked at this as an angle problem, what did we just do? Let's say we had a problem here and it said, here's an angle and we need to bisect it. Are you starting to see how all this is related to these isosceles triangles? If I started off with this angle and I made an arc from the vertex and created 2 points that were equidistant from the vertex, those are the endpoints of the base of my triangle. So when I go through now from there and I find and point this equidistant from each of those edges, what am I doing? I'm creating that other triangle out there so that I have a point to connect, so that I make sure that I'm cutting through at a perpendicular, and I make sure I'm making that angle be bisected. That's how we're doing these angle bisector problems. We're putting our point on, we're making the arc, which is marking the base of the triangle basically. We're going from either side, which is basically giving us a height of an isosceles so we can cut exactly through the middle. No matter what I set my compass on, this point, these points that intersect right here are going to be equidistant from there. So no matter what, it's like I'm forming an isosceles triangle. If I made my tip there instead of up there, it'd still be an isosceles triangle. I'd still cut a perpendicular through the base, cutting it in half, and through the angle, cutting it in half. So now, when you're given any generic angle, you're asked to bisect it, think about what that really means. As you put the point of your compass on that vertex and make your arc, these 2 points you just made are the same as the endpoints of the base of your triangle. And when you put your tip on those 2 points and make your arcs and find out where they intersect, you just found the intersection of where, if you were to draw an isosceles triangle through here, and you go from that point to the vertex, remember, you're basically making the perpendicular bisector through that isosceles triangle. But in doing that, you're cutting that angle in half. That's how we create an angle bisector. This is the foundation that it's on. Okay, to get your class participation points for today, you just have to write down the answers to each of these 4 questions and send me the answers in the right order.